Right, another electronics and networks questions. Kirchhoff's current law. So we're looking to apply Kirchhoff's current law at node A, and then we're looking at our four parts to the question. So we have our, this was my worst sort of question. I think we had about 3 in exams. Verify this equation from this circuit. That scares the living daylights out of me. And then find V2. That's not too bad because they've given me an equation to find V2 and I know all the values. So if I can't do the first part, or if that's going to take a long time, I can leave that for now. Do these other parts because everything I need is in this equation they gave me. I could do B, C and D without this first part, but let's tackle this first part. You've got to be quite good, quite strong on your maths and know your fractions laws to get there. But there is a sort of method to it. We'll start off with Kirchhoff's current law, and then we need to try and get V2, IS and VS into and the resistors into the equation. So I've wrote this one down. Hopefully it's neat enough and readable. So the question is to verify that V2 equals R1 over R2 plus R1 R over R1 plus R2 times the current source plus R2 plus R1 R2 over R1 plus R2 for the voltage source. So quick note, V2 is equal to VA. So let's have a look back here. So this is V2, this is our node A, that's going to be VA. So V2 will be the same as VA because this is 0 volts here as well. So I'm not going to use VA because that's not in this equation, so I'm going to use V2. So looking at Kirchhoff's current law, let's get the circuit back in here. We can see that I2 here is the sum of I1 plus IS. So I2 equals I1 plus IS. Now none of them look like this equation. So let's substitute the current with the voltage over the resistance, because we know voltage over resistance is the current. So V2 over R2 is I2. So V2 over R2 would equal I2. So we're going to substitute I2 for V2 over R2. And great, we've got our V2 in. So I1 we can say is VS minus V2 or VA, that point there, over R1. So it's the voltage drop across R1. So VS minus V2 over R1 plus our IS. There's nothing we can do really with IS, but IS is in our end equation. So that's good. We've got our V2, VS, R1, R2 and IS in our equation. So that's a good place to start. So what can we do with this? Right, so if we split up our VS minus V2 to 2 separate fractions, so we're going to end up with VS over I1 minus V2 over R1, and this is common denominators and fractions, so hopefully it's something you need to know. Just you can combine them and split them and you will get the same answer. So next, if we take this and we take away V2 over R2, it's going to bring this over here, so we end up with 0 equals VS over R1 minus V2 R1 plus IS minus V2 over R1. Now we've got 2 V2s, so what we're going to do is going to factorize them to combine them. So VSR1 the same, plus our IS, then our 2V minus V2s is going to become V2 1 over R1 plus 1 over R2. Now, how have we factorised that? Well, if we multiply it out, you can see minus V2 would become minus V2 over R1, and then minus, this is a plus, but if it's plus and then you have your minus V2 R1, that minus will cancel out that R. So if we look at factorising it out, we can see that V2 times R1 is going to end up being minus V2 over R1, and minus V2 over R1 over R2 is going to become minus V2 over R2, and this minus will cancel out this plus. And also going back, this to know in our fractions, our A over B minus B over C is the same as having A minus C over B. So it's the common denominator rule. So we've factorised that out. So now we need to exchange the 1 over R1 plus 1 over R2, and we need to put in R1 plus R2 R over R1 R2. So how have we made that step? So that step is made by this rule, or fraction rule again. A over B plus C over D is the same as AD over BD plus BC over BD. So again, another fraction rule. So if we look at our R1 plus R2, so if we do our AD, we end up with 1 times R2 over BD, R1 R2 plus BC, so we're going to end up with R1 times 1 over BD, R1 R2. So we can get rid of the times R1, we end up with R2 over R1 R2 plus R1 over R1 R2, and then we can combine these two because they've got the common denominator to be R2 plus R1 over R1 R2, and we can swap these around, and this is how we get from here to here, which again is, you've got to know your fractions, know your maths quite well. So if we add our add V2 R1 plus R2 over R1 R2 to both sides, we're going to move this over to this side, and that's going to equal our VSR1 plus IS. So we've still got quite a way to go to get to here, and the next side is obviously to divide by this chunk here, so to get V2 on its own. So we're going to end up with VSR1 divided by R1 plus R2, R1 R2. So this here is going to sit under here, and it's going to sit under here. This used to make me a little bit uneasy at university as well. But if we look at dividing fractions, so if we look at 3 over 4 divided by 1/8, we can convert that divide, we can change that into a times, and we flip our second fraction, and that should equal the same. So 3/4 divided by 1/8 is the same as 3/4 times 1 over 8, which equals 24 over 4, which equals 6. Let's grab our calculator and double check. So with rules like this, I like to check them, whether I do them in whilst I'm working things out to make sense of it or not. I would quite happily write something like this down in the middle of an exam to prove a rule out. So 3 divided by 4, let's do it on fractions. 3 over 4 divided by 1 over 8, that would give me 6. Now if we start again and I do this, 3 divided by 4, let's do with the fractions. 3 divided by 4 times 8 over 1. And that would give us 6 as well. So that proves the law. So you change your divide to a times and you flip it. So that's what we're going to do here. So we're going to flip our multiplication on the bottom to the top, and we're going to times it, and we're going to do exactly the same here. We're going to change that to a times and flip it. So that ends up giving us VS R1 R2 R1 times R1 plus R2, and our IS plus R1 R2 over R1 plus R2. So we're getting close to our original question. So these two here are going to cancel out. So that's going to give us V2 equals, and we're also going to split out the VS, R2 over R1 plus R2, and then we're going to have our plus R1 R2 over R1 plus R2 IS. And our small is is equal to our large is. And if we rewrite that, we end up with our original equation. So R1 R2 over R1 plus R2 IS plus R2 over R1 plus R2 VS. Hope that's helpful. When we ended up with this bit here, we can split out our VS. That's just from, again, another rule where you can sort of say, oh, 6 over 4 is equal to 1.5, or you can take your 6 out of there and just leave your 1 there. 1 times 6. 6 times a quarter is equal to 1.5, so that's just that rule there. So that's very painful, and I hated doing things like that, doing them questions. Let's do V2. It should be fairly simple. So V2 is equal to the equation here, R1 R2 over R1 plus R2 IS, R2 R1 plus R2, sorry, R2 divided by R1 plus R2 times VS. So our V2 is going to be 16 times 4 over 16 plus 4 times 1, which is IS, that's our 1 milliamp, plus 4 over 20, which is going to be our 4 over 16 plus 4, times 10, which is our VS. And then we can say that that's 64 over 20 plus 40 over 20, which equals 3.2 plus 2, which equals 5.2 volts. So V2 is 5.2 volts. So what is the current in R1? So I1 is equal to VS minus V2, or VA. So I over R1. So we've got 10 minus 5.2 over 16, which gives us 4.8 over 16, which is 0.3 milliamps. So we're 0.3 milliamps through R1. So what's the current in R2? Two ways we can look at this. I2 equals V2 over R2, so we get our 5.2 over 4, which is 1.3. Or we can look at our Kirchhoff's current law. I2 is equal to I1 plus IS, which is equal to 0.3 milliamps plus 1 milliamp, which equals 1.3 milliamps. Hope that's helped you.